In fact, perhaps to conclude today's lesson, what we should talk about is an old algebraic concept called simultaneous equations. Suppose you're asked to solve this pair of equations. You say, well, let's see, if y equals 3x minus 1, and it's also equal to x plus 1, that says that x plus 1 equals 3x minus 1. I now solve this thing algebraically. I get 2x equals 2, so x equals 1. Knowing that x equals 1, I can see that y equals 2. And I see that 1 comma 2 is my solution. In other words, if I want to look at this thing algebraically, 1 comma 2 is the only member that belongs to both of these two solution sets. Now, again, notice how I can solve this purely analytic problem without recourse to a picture. On the other hand, if I want to think of this thing pictorially, notice that y equals 3x minus 1 is the equation of a particular straight line. And y equals x plus 1 is also the equation of a line. Notice that since these two lines are not parallel, they intersect at one particular point. And the geometric problem that I solved on the previous board turns out to be that the point 1 comma 2 is the point that both of these lines have in common. In fact, if we call this line as before L1, and if we name this L2, in the language of sets, 1 comma 2 is what? The point which is the intersection of the two lines L1 and L2. Again, a geometric interpretation for an analytic problem. In fact, notice also how much mileage I can get out of the geometric picture. For example, notice that this region here has a very nice geometric interpretation. It's a set of what? All points which are below this line and above this line. In other words, what? To be below this line, y must be less than x plus 1. And to be above this line, y must be greater than 3x minus 1. Notice then that a pair of simultaneous inequalities, which may not be that easy to handle, are very easy to handle in terms of regions in the plane. Notice also that since two lines can either be parallel or not parallel, we also get a nice geometric interpretation as to why simultaneous equations may have one solution, namely the lines are not parallel and hence they intersect, or no solutions, the lines could have been parallel without intersecting, or infinitely many solutions. The two lines could have been different equations. In effect, I should say what? The two equations could have been different equations for the same line.